What's up, 10C? Hopefully you guys are all staying healthy out there. This video is going to examine X and Y intercepts, and the quiz that you're going to do after this is based off of slope from last week and this lesson, X and Y intercepts. If you're kind of trying to follow along in the note package, you're looking at pages 23 and 24 in the note package, although some of the examples that I'm going to go through here differ a little bit. So what is an X-intercept? What is a Y-intercept? So an X-intercept is wherever the graph crosses the X-axis. And, hopefully we realize or we remember this is the X-axis, this is the Y-axis. So if I have a graph, let's say like this, well, the X-intercept here would be at 6. And that point is actually the point of 6, 0. Let's say I have a point or a graph that looks like this. That's a quadratic function, but it still has an x-intercept, let's say at -9, 0, and this x-intercept at -4, 0. Now, for our purposes, we only look at linear functions, but I just wanted to point out that x-intercepts can occur in any type of function. As well, looking at these 3 points, we always have a commonality. And the commonality in all of these x-intercepts is that the y value is equivalent to 0. Y-intercepts. Well, then that's where the graph crosses the y-axis. Okay, so this is the y-axis. So looking at a similar function, so let's say something like this. Ooh, sorry, it's a bad line. This right here would be my y-intercept. That is the point of 0, -3. Let's say I had a upside down quadratic function here. This has a y-intercept at 0, 5. Let's say I had this horizontal line, and that's right here, let's say. That point is at 0, 9. And so all y-intercepts also have this commonality that the x value of a y-intercept is equal to 0. And so that adds, and understanding that helps us, define things, and it also helps us solve algebraically as well as graphically. So some terminology here. An x-intercept is where the graph intersects or crosses the x-axis. A x-intercept occurs at a point on the graph where, we just said, the y value is equal to 0. Which means I'll always have a point for an x-intercept that is some number, 0. Because my y value has to be 0, and then I could have an x-intercept here, 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 here. Doesn't really matter. Okay, so then the y-intercept. The y-intercept is where the graph crosses the y-axis, like we have just said. A y-intercept occurs at a point on the graph where the x value is equal to 0. And so those x-intercepts always occur at points of 0, some number. So they could be, any point along that y-axis will give you your y-intercept. So to solve, you can either remember this. So to solve for an x-intercept, we make y equals 0. To solve for y-intercept, we make x equals 0. Or the other way that I remember it is to say, just make the other value equal to 0. So if I'm looking at this sketch of a graph right here, I could just look at this and say, well, that crosses the y-axis right there, so that's my y-intercept. And that's occurring at the point of 0, 6. This point right here is crossing the x-axis at -4. So that's the x-intercept, which is occurring at -4, 0. So that's some terminology. Now, there are 2 different ways that we can solve for x and y intercepts. We can solve algebraically, and we can solve graphically. And we're going to go look at both of those. Being able to solve graphically and algebraically for X and Y intercepts is a very important skill as we move forward. So to algebraically solve for the x-intercept, where's my ink? To algebraically solve for the x-intercept, what I'm going to do, we said, is make that other value. So I'm going to make y equal to 0 and solve for x. Okay, and this rule applies to any function. Now, we're strictly looking at linear functions, but it also applies to quadratic functions. The y-intercept. Well, to solve for the y-intercept, we make the other variable, so x equal to 0. And when we do that, we get rid of x, so then we'll just solve for what's left, which should be y. So that's my rule. So let's go look and apply those to a few different examples here. So the first one says, given the equation y equals 2x plus 1, algebraically determine the values of the x and the y-intercept. So I always kind of write this for myself. Okay, if I'm solving for the x-intercept, I need to make y equal 0. And I outlined that rule up here for you. So if I make y equal to 0, I'd have 0 equals 2x plus 1. And now I need to solve algebraically, or algebraically rearrange to solve for x. To get x by itself here, I need to undo all of the present operations. And we usually go through that in a process called SAMDEB. So I want to get rid of subtraction and addition first before I get rid of multiplication and division. Now, I don't necessarily always have to do it in that order, but that kind of makes our lives a little bit easier. So to solve for x here, I got to get rid of subtraction or addition first. I'll subtract 1. So subtract 1, minus 1 equals 2x. Now I need to undo this 2x, and if you remember, when a 2 and an x are right next to each other, they're actually being multiplied. So the opposite of timesing by 2 is going to be dividing by 2. So here, x would equal a negative 1/2. So that would be the x-intercept point of negative 1/2, or negative 0.5, comma 0. Now I want to do the same thing for the y-intercept. Now the y-intercept, I wrote the rule up here. Make x equal to 0 and solve for y. So make x equal to 0. So let's do that. Y is equal to 2 times x, which we're now making 0, plus 1. Well, plus 1. Well, what's 2 times 0? 0, so that's gone. So y is equal to 1, which means that's the point on the graph at 0, 1. So there, I've solved for the x and y intercepts for that graph. Okay, if you think you're comfortable with those processes, solving, the hints are there for you. I'd suggest maybe pause the video and try this now on your own if you want, and then verify with what I do here. Okay, so hopefully pause the video and try this one out. So to solve for the x-intercept, we're going to make y equal to 0. So wherever there's a y in this equation is now going to be a 0. So 3 times 0 equals 5x plus 15. Well, what's 3 times 0? That's 0 equals 5x plus 15. And so now I need to solve to determine, or to get x by itself here. And to do that, I want to get rid of subtraction and addition first. So I'd subtract 15. And remember, this is an equality, so whatever you do to one side, you have to do to the other. Otherwise, you won't preserve that equality. So once I minus 15 from one side, I do that to the other. So I'm left with minus 15 is equal to 5x. And once again, because I have this 5 and the x right next to each other, there's an invisible multiplication sign in there. I just divide by 5 to get rid of that. So divide by 5, divide by 5. So x, once I solve that, is equal to negative 3, which means there's an x-intercept at negative 3 on the x, right? And 0 on the y, because that's what we substituted in. Now I can do the same process with the y-intercept, but now for the y-intercept, we make x equal to 0 and solve. So 3y equals 5 times x, which you're going to make 0 to help me find the y-intercept, plus 15. Well, 5 times 0, that's just gone. So technically I have 3y is equal to 15. And now I need to rearrange to solve to get y by itself. The 3 and the y are being multiplied, so I will divide. And what I do to one side, I do to the other. So y is equal to 15 divided by 3, which is 5. So there's a y-intercept at 5 or at the point 0, 5. So 0 on the x, 5 on the y. Okay, so that's how we can solve algebraically. If you don't already have your graphing calculator, I'd suggest pausing the video. There is some stuff I want to go through with the graphing calculator. And if you go to this graph button, you know, maybe you have some stuff there, maybe you don't. And so there's a few things that I want to write that you need to kind of know here. And there is that graphing button. Now, maybe you like let a sibling or you share a calculator with somebody else in your family. They might have different window settings than you. So what you want to do is just like, let's just go make sure we are all on the same page here. So what I would do is I'm going to go hit the second button. So I hit second and the plus sign, and that's going to get me to the memory. And when I hit the second plus sign, I need to go down to just number 7, which says reset my calculator. And I'm going to pull this up on the calculator here in a second. So I'm going to reset my calculator. And it's like, you want to reset everything? And I say, hit number 1. Say, yep. Reset everything. Yeah, hit 2. And then that's just going to reset. So now we're all, if you're following along with the video, we're all going to kind of be on the same page here. So I go second, memory, so second plus sign, then I go down to reset. I hit enter on that. Do you want to reset all of it? Yeah, hit enter again, reset. So I'm going to go down to reset, hit enter, and then your calculator screen should look like this. Now, when I go to my graph button, you should just have a regular axis, and we should all have the same axes here. The other thing is just looking at some window defaults on your graphing calculator. Sometimes you have to play around with the window setting on your calculator. If your window doesn't look like what my window just looked like, you can always go hit this button that literally is called, or there's one that called window, but we'll say we're going to go to zoom. And then number 6, which is standard. So zoom standard is going to get you back to that 10 by 10 window that we're seeing right here. So if I ended up with a weird graph, so if I end up with like a weird axis and I'm like, well, I just want to see the regular window again, I go to this zoom button and then and that will get me back to my regular setting. Now, well, how do we actually graph on this calculator? That's what we need to learn how to do. And so how to graph is you need to first of all recognize that your calculator only understands equations in the form y equals blah, 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 blah. Okay, so maybe it's like y equals 3x squared plus 7 or y equals 2x. It doesn't understand if you want to put in something like this, 3x plus 7y equals 12, right? I can't put that on my calculator. It has to be y by itself in order for me to graph it on my calculator, okay? How to graph? Well, all I'm going to do is go hit that y equals button, and then I'll type my equations in. Those equations then, when I'm done typing them in, I'll just hit the graph button, and it will come up on that. When I can hit this y equals button, and I'm just going to put a few functions in. So if you're looking to put in a variable, there's this button right here. It's called xt theta 0 right next to alpha, this one right here. Just hit that. So let's say 2x minus 4. Let's put that in as a function. And another one, x squared minus 4. Let's see what those functions look like. So if I hit the graph button, there's my first linear function, and there's my quadratic function. If I only want to see one of them, I can just highlight the equal sign, and then when I go back to graph, it'll only show me one of them. If I just don't want anything there, just go clear what's ever in there. All right, just go look at how to solve for X and Y intercepts. Okay, So to solve graphically for the y-intercept, now this is the easier one to do. So to solve graphically for the y-intercept, what I want to do is whatever my function is, I'm just going to write the buttons down and then I'll tell you what to do. So you're just going to go to trace, and the trace button, and then 0. Now this trace function will let you trace any x value you want. But that's not what we're trying to do. We're trying to solve exactly what is the y-intercept. Now this is tracing x values. And so because it traces x values, when I put in 0, that's going to bring me to the y-intercept. So let's look at an example. So here's an example here. Y equals 2x plus 8. So I'm going to go graph that on my graphing calculator. Y equals 2x plus 8. And I would suggest that you follow along on your calculator so you know how to use it. Equals negative 2x plus 8. So I'm going to go put that in on my graphing calculator. Make sure when you're putting in a negative, you put a negative in, not a minus sign in this case. So negative 2x plus 8. When I graph that, there is my function. And so I'm trying to find the x-intercept. So I go trace. That's tracing any x value I want. I go to 0, and it gives me to the point, and it says right here, there's a point at 0, 8. And so now I know that is my x-intercept for that function. They want me to look at 3y equals x minus 9. Now I said before, can't put that on my calculator. It needs to be y by itself. So what I would do is divide by 3, and what I do to one side, I'll do to the other. So this equation actually becomes y equals, well, this is actually a 1x, so it's 1 over 3x, and then this 9 also needs to be divided by 3, minus 3. So that's what I'll put on my calculator, and I'll go find the y-intercept by going trace x equals 0. Y equals 1/3 x minus 3. I hit graph. It shows me my function there. And because I want to find the y-intercept, I just hit trace. That's going to take me to any value. Usually it actually pulls you up already on the x-intercept, but there is that y-intercept of 0, 3. 0, 3 for this function. If you do notice, and like you should know this already from grade 9, technically if you're already in this y equals mx plus b, whatever the constant is, that's going to give you your y-intercept. Should be a negative 3 there. I didn't include that. But if you know that rule, that's great. If not, that's okay. You can always find it on your calculator. Okay, to graphically solve for the x-intercept. Now, this is a little bit trickier. And so what's going to happen is you got to go hit a few different buttons here. So I'm going to write them down, and then we will talk it through. So I need to go to second trace. Now, when I hit second trace, it's actually bringing me to what's up here, which is the calculate. So I'm going to second calculate. Another word for x-intercepts is a 0. Because x is equal to 0. So we were trying to go find zeros of the graph. Now, when I hit enter on that, and depending on like when you have a function in there, it comes up and it says left bound, question mark. Is it left bound first or what is it? Second enter. Second calculate 0. So then the graphing calculator at the very bottom, it asks you a question. It says left bound, question mark. So you need to drag your cursor to the left of the x-intercept. Now, if I'm trying to find this as the x-intercept, this is left of it, and this is right of it. So when I'm choosing my left bound, so the calculator would be like left, you're going to have to move your cursor over until you're left of it. Once you're left of the x-intercept, hit enter. Then you'll drag it back, because now it's saying, well, right bound. So then you're going to have to take your arrow, drag it right of the x-intercept, hit enter. And then it says guess. Now, it doesn't really matter if you get it close. Usually I try and get it as close as you want. Guess, hit enter, and then it will tell you where the x-intercept is. So a little bit complicated process. I wrote it there in the notes. It's also at the at the top of some other questions here. So y is, we said this was y equals 1/3 x minus 3, and that's the function that's already on your graphing calculator if you're following along. So that's this function here. So what I'm going to do is go to second calculate or second trace, which gets me to the calculate function. I'm trying to find a 0. So then we have a question down here. It says left bound. Well, my x-intercept is way over here at the side of the screen, so I'm already left of it, so I can hit enter. And then it gives me a little arrow. It says, okay, I'm going to try and find some x-intercept between here and here. So now I got to get right of that. Well, I'm pretty right of it now, so I'll hit enter. And then I'm guessing, I don't know, it looks like maybe it's somewhere right around here. So I hit enter again, and then it tells you there's a 0 at 9, 0. So I could write that down for that function. So there's a 0 at 9, 0. And I'm going to do the same thing here. Y equals -2x plus 8. So -2x plus 8. Once I have that function ready, I can go to graph, and I'm trying to find the 0. So second trace, which gets me to the calculate function, I'm trying to find a 0. So left of the x-intercept, well, the x-intercept is way down, is right, that's the x-intercept-ish. So I got to go left of it, so somewhere over here. Right of it, I got to go to the right side of it, hit enter, and where do I think it is? I think it's like right around here. Then the calculator tells me there's a point at 0, 4. So the x-intercept for that function is at 4, 0. Now I could also do that algebraically, but that skill can actually help you with factoring and doing a whole bunch of different things once you get into, 20-1, 20-2. So I would suggest that you make sure that you know how to use your calculator comfortably before moving on. So that we said there was a x-intercept at -4, 0 for that function. Okay. I had some extra questions here. If you want to go try these on your own, I would suggest going ahead and doing that. I'm just going to write the answers here if you want to try that graphically on your calculator. I'm not going to demo it. So if I actually go and figure these out, there is a y-intercept at 0, 4 and an x-intercept at 8, 0. Okay. This other question here says, given the equation graphically determined. Now I could go through that same process, but just because this video is getting a bit long, I'm not going to do that. Just remember, if you're trying to solve a question like this, you got to get y by itself first. So I'd have to add 4x, or I could move to y, but I'm going to add 4x and -12 at the same time to get those to the other side. So now I have -12 plus 4x equals 2y, and then I'll divide by 2 to get y by itself. So y is equal to -6 minus 2x. Okay, remember you can't put this function on your calculator. You got to solve algebraically to get y by itself. All right, so hopefully that helps you a little bit. Please, if you have questions, fire me an email or a mine. Come to my classroom sessions or open question sessions. And then once you're comfortable with that, both algebraically and using your calculator, attempt the quiz on slope and x and y intercepts. Okay, thank you for listening.